I'm the founder and chief scientist of the Internet Computer Project. And Internet Computer is a blockchain, but it's a very different kind of blockchain. It has very different properties. It's a shared nothing blockchain. There's no single technical element of the Internet Computer that's present in any other blockchain on Earth. The whole thing was architected from scratch. Really, efforts starting thought process a long way back in 2014, 2015. The project really started sort of becoming a thing properly with employees and so on. Around 2016, when it was incubated by String Labs, raised money in an ICO in February 2017. The foundation was created October 2016 and very quickly began scaling out. And this was produced by the biggest R&D operation in blockchain. So Internet Computer is the product of hundreds of person years R&D, which is quite unusual in the space. So if you're wondering why some of the things that we cover don't sound like a traditional blockchain, that's why. It's a very different kind of thing. It runs on a completely different architecture, has a lot of novel cryptography. The DFINITY Foundation, I think, is probably one of the largest teams, if not the largest team, of sort of famous and well-known cryptographers in the world. And that enabled us to create a lot of custom math and so on, powering this thing. So the title of my talk is Cypherspace as Cloud 3.0. And, obviously with Ethereum and so on, we gained the ability to run smart contracts in Cypherspace, but they're very limited things. They can't even store a phone photo. They can only store a few bytes of data, and they're very computationally constrained. And we always thought of the Internet Computer really as a cloud, another kind of cloud where you'd build using smart contracts, but you could build anything. So here's the kind of general vision that the Internet Computer extends the public internet, and it extends the public internet with serverless cloud functionality, powering systems and services that are unstoppable. They run on the internet and become unstoppable like the internet. They're sovereign. They aren't beholden to big tech platforms and have no kill switches or back doors in the same way that nobody can cut you off from the internet. They're tamperproof. That means that their logic and data can't be hacked and can't be corrupted by something like ransomware. They can be DAO-powered, and that means they can be exclusively controlled by community or enterprise DAOs. They can be autonomous, which means they can exist independently, like immutable, like just software rails that are in cyberspace that never change and everyone can trust will never change, or they can be updated by a DAO. And this is actually a big one we'll get to that very few people understand, but these systems and services will be lower cost, and they will require fewer personnel to develop and support. And as we'll see later, that's important because the single biggest cost in IT is IT personnel, about 36% of the $5 trillion we spend a year. So the general vision continues, that we believe that tech history arcs towards public networks. So that you go from private infrastructure to public networks. And an example of this, of course, is the internet itself. Back in the 1990s, Microsoft and Oracle proposed this thing called the information superhighway, which was going to be a sort of walled garden network. And, nobody wanted that. And I think the first edition of Bill Gates' book proposed this thing. The second and third edition switched to calling the information superhighway the internet. And the internet is created by private routing devices, things like Wi-Fi routers, that you pay to peer to other Wi-Fi routers. And essentially, these private routing devices, privately owned routing devices, are connected by this decentralized, open TCP/IP protocols to form a public global network. And so what we want to do is the same thing for the legacy IT stack. Legacy IT stack is cloud services like Amazon Web Services, servers, databases, web servers, CDNs, firewalls. And we want that to be replaced by the Internet Computer, which is created by private node machines connected by the open decentralized ICP protocols to form a public, serverless, autonomous cloud. So let's just think about what the network is for a second. You might be wondering, how does this work? Internet Computer is created by ICP, Internet Computer Protocol, which is the most advanced network protocol ever devised. This is a simplification, but it gives you an idea. So you have these people called node providers, and they're independent parties, and they own and operate node machines in data centers worldwide. And this is actually standardized physical hardware. So the internet computer runs on a sovereign network, not cloud. So most blockchains today don't actually run on sovereign networks. They run on existing cloud services. So the numbers vary. I mean, some people say it's like 69% of Ethereum validators are actually on Amazon Web Services. Hetzner, which is a big European cloud, hosted about 40% of the Solana network and more than 1,000 nodes, and recently it switched them off and they just disappeared. So most blockchains today, proof-of-stake blockchains, run on cloud. The internet computer is more like Bitcoin in that sense. Like Bitcoin's created by dedicated hardware, like ASICs that perform hashing, proof-of-work computations. And the internet computer is also runs on this dedicated hardware, which is formed into a sovereign network. So Internet Computer Protocol combines these node machines to form efficient subnet blockchains. And these subnet blockchains combine nodes from independent node providers, different data centers, different geographies, and different jurisdictions. And this is something called deterministic decentralization. And it means you can massively reduce the replication factor, which is something you need to do to bring costs down to produce a cloud in Cypherspace. So that means that these node machines don't come. They're not owned by the same person. They're not in the same data center. The data centers aren't in the same geographical region, and they're not even in the same jurisdictions. That's how you get the properties of a blockchain with low replication. And these subnets, of course, add capacity for hosting something called canister smart contracts. Canisters are an advanced evolution of smart contract technology. And what's cool is that people use the word subnet. Actually, it came from us in 2018. Avalanche says it has subnets. They're very different things. Those are standalone blockchains. Internet computer subnets are true subnets in the sense that they're combined to create one stateful serverless autonomous cloud with unbounded capacity. When you build on this thing, you don't have to be aware of the underlying subnets. Every canister can talk to every other canister. So you create a single environment. It's a sort of seamless universe for tamper-proof code units without servers or instances. So it doesn't matter what subnet your canister smart contract is hosted on. It can directly call into any other canister smart contract. And that, of course, is serverless cloud functionality. The difference between something like Amazon Web Services serverless cloud, which is, people talk about serverless being the next generation of cloud. The difference is that the internet computer is stateful. That means that the code actually has data associated with it. Without getting too technical here, the big advances with the internet computer, that the data sticks to the code. You don't need a database, you don't need a file. In code, you could just create a database by saying, var db equals new hash map or something like that. Essentially, each individual canister can run in parallel. It contains some WebAssembly bytecode created using any language, any major language, and it contains these persistent memory pages. So you don't need to think about saving something into a file system or a database because the memory pages themselves persist. And this is actually a big advance that goes far beyond blockchain. So what you end up with is this public stateful. Stateful just means that it stores data, right? Maintains data. Stateful serverless cloud. And serverless just means that your code isn't aware of any nodes or subnets or anything like that. It's just, it can call directly into any other code if it's got the permissions. So you've got a public stateful serverless cloud where software is tamper-proof, which means that it always runs the code you expect against the data you expect, and unstoppable. Of course, blockchains are unstoppable by design. And you can build almost anything at all with this network. So let's think about some applications. And one is Web 3 to Web 3.0. So Web 3 today, again, people aren't necessarily always aware, but Web 3 today really is characterized by tokens and NFTs. And when you see something that is described as being built on a blockchain, it very rarely is built on a blockchain. It's built on Amazon Web Services. And then, if you're interacting with a social media thing that's described as being built on a blockchain, periodically it'll say, hey, why don't you buy this NFT or something like that? And it's switching you out to a wallet. And so we have this architecture where, everything that's Web3 is built in Amazon Web Services or Google or something like that, some other big tech cloud service, and just the tokens are kept, and tiny bits of logic and data are kept on the blockchain. Web 3.0 is about full stack decentralization. So the entire system or service is built on the blockchain. There's no Web 2.0 big tech component. And that's a big change from Web 3, of course, because Web 3 really involves 99.9% of the data and computation being on big tech, on centralized services, and only a tiny little bit of the data, the tokens and little bits of DeFi logic being on the blockchain. But that's a widely held misconception in the space, that somehow Web3 is about running systems and services in decentralized ways. None of them are run in decentralized ways. Only the tokens are held on the blockchains. And actually the blockchains themselves actually often run on cloud, as I mentioned. So how can we anyways move this game from Web3 to Web 3.0? Well, this is how the internet computer works. These canister smart contracts actually can process HTTP. So a Web3 experience is served directly from the internet computer, directly from these canister smart contracts into the web browser. And a Web 3.0 internet service might comprise of hundreds of thousands of canisters in principle. It's different to a traditional blockchain in the sense that rather than the user paying for computation, these canisters pay for their own computation. It's called reverse gas. They're charged up like you charge an electric car up. If a Tesla runs out of out of electricity, it just stops and you have to charge it up again. These things are the same. You charge up the software with something called cycles. It burns through them. If you run out of cycles, you have to recharge it. But it means that users can interact with these smart contracts without having any tokens or anything like that. They can just talk to these smart contracts directly over the web. Rather than having a wallet, typically you have an identity framework that creates a secure session for the user interaction to occur within. And naturally, of course, you've got a key somewhere on your device, and that key transparently is being used to sign these sessions. That's the pink key. And then this is the crazy thing. The internet computer is actually signing the responses. And these secure sessions allow users to transparently create multiple transactions a second. And that's necessary, of course, because the entire experience is created from the blockchain. It's very different to something where your experience is coming off Amazon Web Services, and then, once in a blue moon, you do something and you have to get your wallet involved to get an NFT or something. So this is where, it sounds technical, but this is the underlying technical revolution. Every interaction can be verified using ICP's master chain key. So in principle, this is unlimited. The internet computer can be signing trillions and trillions of transaction results a second. And all of these signatures verify using this master chain key. And to get an idea of it, there's the number. So if you want to interact with the internet computer and your piece of software, all you need is this master chain key. It's 96 bytes. So you could be, you could be some code inside a web browser, right? It could be a proxy on the system. As long as it knows this 96-byte chain key, you can verify your interactions, and you can also know when you verify the interaction that the thing's running correctly. And this is the underlying revolution, or one of the many revolutions that makes the internet computer possible. Autonomy is sovereignty. So the internet computer is actually controlled by something called the NNS, and each service can be controlled by something called an SNS. So NNS stands for Network Nervous System, and it's a kind of DAO that's integrated into the protocols, and it controls all layers of the network. And it allows the network itself to be autonomous. It doesn't need to fork. People propose updates to the network protocol, to this network nervous system. If they're adopted, it pushes them into the network. And in the first 2 years in production, the internet computer was upgraded more than 145 times. 145 protocol upgrades occurred seamlessly without interruption to service, and without a blip. It's never gone down. It's never been hacked. and it just continues evolving and improving all the time. Meanwhile, people are building these services on the internet computer and putting them under the control of community DAOs using this service nervous system technology, which is actually capable of updating a running service in a similar way. So fixing Web3, I mean, internet computer can solve for the pervasive centralization within the Web3 ecosystem. So this is typically how a Web3 service works today. You know, so you've got Ethereum with some smart contracts and some tokens and NFTs maybe. But in the middle, you've got typically Amazon Web Services that's running all this legacy IT, like, you know, Red Hat operating system, MySQL database, Nginx web server, Memcache to speed it up, maybe some kind of containerization with Docker and orchestration with Kubernetes and things like that. And this is where all the hackers go. This is where the censors go, gatekeepers and so on. And of course, you've got to trust the developers. Whoever has the username and password to Amazon Web Services can just log in and arbitrarily modify user data and the experience and potentially set up a hack. And this is why, you know, we keep getting all these kind of security breaches and problems. So, you know, with the internet computer, you can completely replace that with canister smart contracts. Just get rid of legacy IT entirely, keep all your data and computation on the internet computer, maybe even put them under the control of autonomous governance, service nervous system, and, you know, now you're secure and decentralized. You've got rid of legacy IT and the main agent of problems. Web 3.0 is a full stack decentralization, and it offers new experiences. So internet identity is a different way of is how people typically log in, but there are different identity platforms on the internet computer. And it combines chips inside your devices like phones and laptops, which can hold private keys securely. You can't get the private key out of the chip, and the experience inside the web browser can interact with that chip using something called WebAuthn. So this is how it works. Here's somebody going to OpenChat, which is a sort of messaging service, clicking Launch App. It's within the browser. They're choosing an internet identity, again within the browser. And then they're, you know, authorizing it. That could be via fingerprint, it could be by PIN, it could be by Face ID, but it's using the operating system's secure circuitry to authorize the session being signed inside this TPM chip. You can add as many devices as you like, and boom, you're in. It's extremely user-friendly and seamless. About 2 million identities have been created so far, and there are more than 100 dApps using internet identity for authentication. You know, to really understand the internet computer and what it's capable of, you have to have a look at, you know, for yourselves and into the environment. OpenChat's one of these things. And actually, it was the first true open internet service. It runs autonomously under the full control of what's known as a service nervous system, this DAO. And it's kind of cool because you can hold, like, it's socialfy. So your chat account is also a crypto wallet, and you can send things like Bitcoin in chat messages. We'll get to chain key Bitcoin, but you can send Bitcoin with 1 second finality using a chat message. Again, never been hacked, never any problems. Hot or Not, I think, illustrates some of the kind of interesting ways you can create decentralized economies with more interesting tokenization. Hot or Not is like a tokenized TikTok, essentially. People bet on whether a video is going to go viral or not. You can earn hot tokens. Obviously, people who create viral videos receive hot tokens, and the idea is that eventually advertisers will have to acquire hot tokens in order to pay for advertising. So that's how you create a fully decentralized economy. This runs under an SNS2. It's a bit out of date. It's not ICDEX. I think it's IC Lite.io. But this is like a full order book exchange, like FTX or Coinbase or something like that. But it's created by a smart contract. So, you know, this interface you're seeing, which looks like a traditional crypto exchange, is actually being created by a smart contract. When you're interacting with this, you're interacting directly with a smart contract. And when it's assigned to a DAO, eventually it's not under the control of a DAO yet. Every update to that exchange will pass through the DAO to be transparent. There's no backdoors for someone like Sam Bankman-Fried to secretly extract all the crypto inside, right? So I think this is the next generation of finance that we're heading towards. And, you know, there are a lot of people, you know, building these things that take Web 2 concepts and create Web 3 versions of them or Web 3.0 versions of them. So I know I'm a bit over time, but I'm going to try and accelerate. What's important, I think, what's profound about all this, which is easy to miss, this is something that's very, very different to a normal blockchain. This is providing a completely new way to build. You know, and to understand this, you just have to look at the Web3 services that are running. So there's no cloud, there's no database servers, right? There's no web servers. So these Web3 services can be built entirely from canister code, right? The network is the tech stack. So people are building these highly sophisticated online services without using traditional IT. None of it. No Amazon Web Services, no databases, no web servers, no memcache. The whole thing is just, this is a complete alternative stack. And that's actually kind of profound. Another one is there's no firewalls, there's no seam logging, there's no security paraphernalia, right? Like OpenChat isn't protected by, Bitcoin's not protected by firewall, right? Smart contracts on Ethereum aren't protected by firewalls. They don't need it. It's tamper-proof. Smart contracts are tamper-proof. And as a consequence, these services, these Web 3.0 services built on the internet computer, also don't need firewalls and security paraphernalia. And that's a massive advance, especially when you think about all of the hacks and problems that are happening today in IT. I think MGM just got hacked, right? The whole casino thing went down. All of their casinos worldwide stopped working. Another kind of profound thing is these are cool services. They're very sophisticated, but they've got tiny, oftentimes pretty small tech teams developing them. I think OpenChat's 3 guys. That exchange is, I think, 12 people in Shanghai. Not all of them are devs. Far, far fewer engineers are required to create these services. We'll come back to that. Just broadly, other stuff with the internet computer, going back to the chain key cryptography it uses. The internet computer smart contracts can create transactions on other blockchains without having a private key. Like, just think about that for a second. You can create a transaction on another blockchain without having a private key. One of the applications of this is a thing called chain key Bitcoin. People are using internet computers as a layer 2 for Bitcoin. You create a Bitcoin twin called chain key Bitcoin. And once you've done that, you can transfer the Bitcoin almost for free with 1 second finality. And it's a Bitcoin twin, so you can send it as well directly to a Bitcoin address on the Bitcoin chain, right? So this was recently integrated into the My Lugano app in the municipality of Lugano. It's a city in Switzerland. And time flies. It's a month ago now, right? But it feels like yesterday. But I bought some coffee using Bitcoin in Lugano. It's fantastic. You just go up and you transfer the Bitcoin, you get your coffee, done. So we expect to see other applications of internet computer technology, such as internet identity, within these government and municipal environments. If I had time to update my deck, I'd have talked about Oisi, which we just demonstrated in Hong Kong, which is a web-based Ethereum wallet where you can manage Ethereum assets on the Ethereum chain, including using things like Uniswap, without need for MetaMask. Another crazy advance. So government, this is something actually that Origin have been working on. The Feder Italy system, which provides this 100% made in Italy certification, runs on the internet computer. And that's more like a traditional application of blockchain. But the nice thing about this is the whole thing's on chain. You don't have any security risks, like all the web experience and data that's associated with this supply chain tracking is on the blockchain. It's not something where you've just got a few tokens or hashes on the blockchain. So what you're probably seeing as well, asking yourself, this is a big deal, right? Is this a better stack? Because actually the mission of the internet computer is to try and replace traditional IT in as much as possible. Web 3.0 enterprise is going to be a real thing. Andreessen Horowitz said software will eat the world. We say smart contracts will eat software because, and I want to say smart contracts, of course I mean fast, scalable smart contract tech like canisters, because it has overwhelming advantages. Like, it's unstoppable, it's tamper-proof, but it's also a great simplifier. So if you think about, the world spends $5 trillion on IT, or will do in 24. 36% of that is actually IT personnel. So that's $1.8 trillion. If you reduce complexity overall by 75%, that's $1.35 trillion in potential savings. We would say that, as we go forward with the internet computer, it should be possible to reduce the complexity of systems and services by 90% plus. It's an incredible, stateful serverless cloud is an incredible simplifier. So this is actually one of the main reasons for enterprise. It's a subtle one. There's also other things, like enterprise spends this year $912 billion on software, like Oracle databases and things like that. Well, you don't need those things if you're building on a stateful serverless cloud. You can get around that. It's another huge cost. Obviously, cloud services and data center systems, 600 billion and 224 billion relatively. We hope eventually a lot of that can move over onto the internet computer. Cybersecurity, by the way, cost the world in 2022 172 billion. That's just the cost of cybersecurity. Imagine the advantages of being able to build a system that doesn't need to be protected by firewalls. Huge opportunity in itself. CPS incident costs of 50 billion. In reality, they're much greater. Like, in 21, there was this Colonial Pipeline hack, and the oil stopped flowing from Texas to the eastern seaboard of the US. The refineries ran out of oil, the gas ran out, and there were these huge tailbacks. Like, the cost of that economic disruption from a simple ransomware attack, I would imagine, runs into the many tens of billions of dollars. Something we've got coming up, you'll hear more about this, I think, so you're one of the first people to hear about it. It's something called the Utopia Initiative. So we're sort of leaning into the enterprise space, or will be leaning into the enterprise space increasingly. Utopia stands for Unstoppable, Tamper-Proof, Open Platforms for Independent Autonomy. And the purpose of this is to allow enterprises to use internet computer technology to spin up these private clouds, and they can partition control of the underlying resources to get many of the properties that you get within the internet computer network, but maybe at lower cost, reducing the level of replication. A lot of businesses, it's a big leap for them to suddenly build on a public network. This provides them a way of to use the technology without having to initially at least connect to a public network. It's something they can do later on. And one of the big applications is going to be within Europe and Asia, because there's a problem when you build on American technology, like Amazon Web Services and stuff. There's a danger your data's being sucked out, put in the NSA's Palantir database, and of course they have a kill switch. And all of society runs on systems. We use social media to orchestrate our social interactions, and of course enterprise and government runs on software. So there's an issue there, because you don't want to abrogate your sovereignty by giving other people kill switches. So this is something I think we'll see more of, and Utopia is one of the tip of the spear that will help areas like European Union develop sovereign cloud. Last thing, AI. I don't know if anyone's seen it. There's actually a large language model now running on the internet computer as a smart contract, and that surprised even us, because we're planning on adding. Proposing standards for AI compute nodes and various other things that will make this more performant, but people are doing it already. AI is going to be central to everything, enterprise and Web3. If you're not doing AI, then you're making a mistake. And I'm happy to say that it's on the internet computer. So our mission, of course, with all this is to enable the reimagination of humanity's systems and services through full stack decentralization on the internet computer. Today, if you're wondering, the internet computer is doing the equivalent of about 250,000 Ethereum equivalent transactions a second. So there's a lot of activity on the internet computer. And of course, these huge numbers are because it's not just like token and NFT transactions. Entire services are running on the internet computer, and it generates a lot of transactions. It's by far in terms of the actual compute going on a blockchain, it's it's doing many orders of magnitude more computation every second than any other blockchain. In fact, if you summed up all the blockchains on Earth, their total computation would also be many orders of magnitude less than the computation occurring on the internet computer. DFINITY Foundation, you probably know lots about. We're based here in Zurich, not far from here. We've got a team of about 270, but there's actually a Zurich HQ very nearby in Genferstrasse, and we've got 140 people there. Something that you may or may not have heard of, we just launched this thing called the ICP Asia Alliance, and generally speaking, there are these ICP hubs being launched all over the world at the moment, and they're doing a great job of decentralizing growth, and they're integrating with this thing called the ICP Accelerator, which is a slightly different model for us to help Web3 startups that want to build on the internet computer get going. That's it. And I know I've gone over, but if you grab these emails, that's a great way of getting in touch with SBNity. Thanks.